This is Astrophysics, Telescopes, Lesson 5, and this is CCD, or Charged Coupled Devices. So the human eye is not very sensitive to light compared with photographic film, and in recent years CCDs have greatly improved on the sensitivity of photographic film, and virtually all modern telescopic images are obtained using CCDs. So let's look at the structure and operation. So it's a silicon chip divided into picture elements, or pixels. And incident photons cause electrons to be released. And the number of electrons liberated is proportional to the intensity of the light. So intensity is basically the amount. It's nothing to do with the individual energy of the incoming photons. So what happens is these electrons are trapped in potential wells in the CCD. And an electron pattern is built up, which is identical to the image formed on the CCD. And then when exposure is complete, the charge is processed to give an image. Alright, let's move on to quantum efficiency. So the quantum efficiency of a pixel is the percentage of incident photons that liberate an electron. So with a CCD, this is usually at least 70% and can be up to as high as 90% with certain light wavelengths. When we compare that to photographic film is typically 4%. So a CCD is about 20 times more sensitive to light than a photographic film. Alright, so some advantages of using CCDs. So they have a much higher quantum efficiency than photographic film and are therefore far more sensitive to light. They can be used to record changes of an image. They are sensitive to a wider range of wavelengths than the human eye, typically between 100 nanometers to 1100 nanometers, so all the way from UV to infrared. Human eye is around 350 to 650 nanometers, which is the range of the visible light spectrum. And they have a fairly constant quantum efficiency across the visible light range of wavelengths, unlike the eye and photographic film. So what I'm going to do now is give you a 6-mark exam question about CCDs. There's a bit more information in the mark scheme that we've not quite covered, but obviously we're going to go through it anyway, so it doesn't really matter. So you can have a go at this if you wish. Many astronomical observations rely on a charge coupled device, CCD, to obtain an image. Describe the structure and operation of the CCD and discuss the advantages of using a CCD for astronomical observations. So if you've taken extensive notes, you can do this one of two ways. You can either use your notes to help you answer the question, or you can go through the notes and then put them to one side and try and answer the question without them. Alright, so let's look at the mark scheme. So points that we can use to support the explanation. So CCD is a silicon chip divided into picture elements. Each picture element is associated with a potential well in the silicon. Incident photons are focused on the CCD, and the photons cause the release of electrons within the semiconductor. The number of electrons liberated is proportional to the intensity of light. So if you double the intensity of light, you'll get double the number of electrons liberated. Electrons are trapped in potential wells. Then you get an electron pattern is built up, which is identical to the image formed on the CCD. When exposure is complete, the charge is processed to form an image. So some advantages: you've got high quantum efficiency, greater than 70%, as high as 90%. Light integration, using long exposure times to capture faint images, which is obviously very useful in telescopes. A device can be linked directly to a computer for capture and analysis. So it may seem a bit abstract learning about CCDs, but it's on the spec, and it's just one of those things that you're going to have to put some time in and learn about. And if you get a 6-mark question, hopefully, if you learn this well enough, you'll be absolutely fine in your exam. Anyway, thanks for watching.